everyone. So I would like to welcome you all to a session on hybrid approach to performance testing. So let's give a minute so that folks can join in, right? Great. So we can see folks joining in. Great, great. I hope you got all had, have been able to learn quite a lot from the previous sessions, and hopefully you get to learn a lot from this session as well, right? So again, hello everyone. I would like to welcome you all to a session on hybrid approach to performance testing. I am Mohammed Afzal, your host for the session. I would like to introduce Mary, who is working as a developer advocate at K6.io, a Grafana Labs company. She is one of the thought leaders in the field of performance testing. Mary helps developer and testers by educating them about the recommended and best practices in performance testing. Welcome, Mary.
Thank you. Thank you, Afsal, for the really nice intro, and I'm really happy to be here.
Great. So before I hand over the stage to Mary, there are a couple of things I would like you all to please note, and I would really appreciate it. So the first thing, all the sessions are being recorded. You can watch it later on the official YouTube channel of Lambda Test. And second, the session will be followed by a Q&A session. You'll find a little toggle that says Q&A on the right pane of the screen to ask the questions. I hope I'm clear on that. I would like to hand over the stage to Mary. Over to you.
Thank you. Let me just try and share my screen. Okay, so as Afsal said, my name is Marie. I currently work as a developer advocate. This is a pretty new role for me. I've only been doing this for 1 year. But prior to this, I am a software tester. So I've been doing software testing for about 10 years. And today, I'm going to talk about what this hybrid approach to performance testing is. How is it different? And hopefully you can learn something new today after this session. But first off, so if you want to grab the link for my slide, so I've added a QR code here, so you can take a photo of it so you can follow along. But if not, I think Afsal will also share the link of my slides in the chat. So, what are we going to talk about today? So, unfortunately, I'm not going to be talking about this type of hybrid. But, I guess it would be really cool to see a Liger as part of a conference, but we won't talk about, this specific hybrid. But instead, I'll be talking about this type of hybrid, which is, a mixture of other things, especially, two other things. And it could also be about finding that sweet spot in the middle. I wonder if there are any parents here in the chat. So every time I do my talks, I always like to include me being a parent and something that my daughter, would like to watch. So it's not going to be related to performance testing, but just so everyone can understand this hybrid approach. So when my daughter was young, she really liked watching Peppa Pig and Blippi. Um, I dislike watching Peppa Pig. Like I like to be honest, I found Peppa Pig quite annoying, but it's something that my daughter wanted to watch. Then on the right, so I was watching parenting shows such as Motherland or Modern Family, but it's not really something that my daughter can watch. So when we found out about this show called Bluey, it's something that that she can enjoy, and it's something that I can also enjoy. So suddenly we found this hybrid in terms of like watching a show that's both in terms of her like like something that she wanted, but it's also applicable to adults. So we finally ended up finding that sweet spot when it comes to watching shows. So anyway, back to performance testing, because that is the topic for this talk. So whenever we try to create a performance testing strategy, teams would either have the option to focus on either doing back-end performance or front-end performance. But what if you can do both? So what if you can find that sweet spot so that you can have a holistic overview of measuring your application's performance, both from the back end and the front end perspective? But before I talk about what this hybrid approach is, because I'm not sure how many beginners are in this talk, so what I'll do in the next following slides is I'll just explain some key concepts about backend performance and then front end performance. So let's start with backend performance. So essentially, when you are testing for backend, you're targeting the underlying infrastructure of your application. So this could either be testing a microservice, it could be testing a database, or an infrastructure that is not necessarily exposed to your users. When you talk about backend performance as well, so this not only provides you with information on your application's latency or your application's response time, but it can also give you insights on different aspects of your application. So, for example, it can give you information about your application's scalability, how available your application is, the elasticity, the reliability, and the resiliency as well. So just to expand a bit on some of these key, concepts. So when we talk about the scalability, this is when you're trying to measure your system's ability to add, to remove, or to reconfigure, any of the hardware, software, or any other resources to make sure that it can handle the increase or the decrease in the usage. And then when we talk about elasticity, for example, so this is your system's ability to be able to automatically scale up and down to meet the demands from your user. And then when we talk about resiliency, so this is when your system can basically react to failure and still remain functional. So if you look at this, when you do backend performance, like there's a lot of different attributes that you're also covering. So it's not just about measuring how quickly your APIs or your database can return the specific responses, but it also covers these certain attributes. And then when we think about load testing types as well from a backend perspective, so there seems to be some misconception that people might have around performance testing versus load testing. So when we think about load testing, it's just one part of performance testing. So performance testing is the umbrella term. But then under performance testing, you have a specific type for load testing. And then underneath load testing, there's also different types of load testing that you can perform. There's smoke testing, there's the load testing or average load testing, and then there's also stress testing, spike testing, and then we also have soak testing. So I'll give a quick introduction about these different types of load testing. So the first one is called smoke testing. So smoke testing from a load testing perspective, this is where you verify that your system can handle the minimal load without any problems. So this is quite useful, especially if you want to verify that your test script doesn't have any errors, or you want to verify that your system still works as expected, but you don't want to introduce the average expected load. You just want to make sure that your system still works if it's been exposed to a minimal number of load. And then load testing in itself, I think this is one of the most common load testing type that's out there. And this is basically checking how your application is behaving if it's been exposed to a normal or typical load. So it's quite useful when you have situations that you want to assess the performance of your application, and then you want to identify areas of degradation during, like ramp up period. So it's quite useful to do load testing in those cases. And then stress testing, on the other hand, so this typically assesses how your system performs at its limit. So this is when you want to verify that your system can handle the maximum expected load. So the expected load in this case is higher than the average traffic. So if you have situations, or if you have systems that receive higher than usual workloads on events, such as if you've got like HR system that processes like paydays, or like end of the work week, we have to submit like our timesheet. So this might cause a above average traffic. So performing stress testing in those cases are quite useful. And then there's also spike testing. So this is a variation of the stress testing, but the main difference with spike testing is the load is very sudden, it's very abrupt, whereas with stress testing, it's quite a gradual approach. So you do spike testing if you want to verify that your system can survive if it's been exposed to a sudden and a massive rush of like resources. So it's quite useful when your system may experience events such as Black Friday sales, or if you have ticket sales for like famous bands or like famous music artists, where you know that you're going to receive a high amount of traffic in a short period of time, then it's quite useful to perform spike testing. And then finally, you also have soak testing. So soak testing, so this is concerned with your system's reliability over a much longer period of time. So this is quite similar with, let's say, a load test, but then with soak testing, you try to extend that test for much longer. So the time is extended, and I've seen some scripts where they try to do soak testing for like 2 hours, even like 6 hours, just to see if they find any like memory leaks or any like intermittent issues that might arise. So when it comes to specific, tooling, most performance testing toolings out there. So I've added quite a few here. There's Gatling, K6, of course, JMeter, Artillery, and Locus. So most performance testing tools out there, they simulate the traffic that's coming from your real users by sending a bunch of requests simultaneously. So the most commonly way of doing it is sending requests via the protocol level. There's different protocols out there, but the most common one is HTTP. In terms of advantages of backend performance, so many backend performance issues, it can really spiral out of control if you try to leave it right at the end. So I guess this isn't just about with performance, but with other types of testing as well, where if you try to leave it on a much later stage, then it can be expensive to fix. One advantage of backend performance is it can be started earlier on, and it can be integrated during development cycles. I know that there were a few speakers today talking about shift left approach. So with backend performance, this can also be added earlier on, and you can help promote the shift left performance testing. You can add this earlier on because like you can just target specific API endpoints, or specific components, rather than doing a full-blown, I guess, like performance from like an overall application perspective. So you can start this earlier on. You can start this independently, especially if you're working on like different teams. So you can target, different components of your application. You can choose which API endpoint to hit, how hard you want to hit that endpoint. You can also target like specific user flows. So it doesn't always have to be an end-to-end performance testing. Finally, as well, so backend performance testing, I find that they tend to be less resource intensive, and they don't really spin up actual browsers because they're just protocol level requests, so you can easily ramp them up. It's just a matter of sending HTTP requests, which is something that you can scale pretty cheaply. And it can also promote this continuous testing approach to performance. So by using modern tools, then this can really help you promote that continuous feedback by making sure that you have performance testing on every different, I guess, like life cycle of your like software development. So if you have modern tools, K6 being one, then it's quite useful, I guess, to promote this continuous testing approach. When there's advantages, then of course there are also limitations. So backend performance testing, they won't really tell you anything about what's happening on the front end. So essentially, it ignores the user experience. Your test scripts can also get lengthy if you try to create complex user flows. So if we, let's say, compare something on the front end, like a login script, like popular frameworks out there, like it's very easy to simulate a login feature if you want to do it, from a browser. But then if suddenly you want to convert that into a protocol test, and there might be some additional cookies or additional header that you need to pass, then that can get very complex. When you work with microservices based applications as well, since there are many components to track, backend performance can be difficult to determine where to look. So as your application grow, it can also be quite challenging to maintain the backend performance scripts. Now we move on to front-end performance. So when it comes to front-end performance, this is where we verify the user experience mainly on the browser level, because this is what mostly our users use on a day-to-day basis. So with front-end performance, this focuses on everything that your users see, whether they are accessing your web application on a laptop or on other devices. So this might involve automating like certain user interactions. So for example, we can navigate to a page, we can click on a button, fill out a form, and then you want to measure what is the response time after a user fills out the form. How long did it take to basically render the important components that you're showing on a browser level. So when it comes to the front end performance metrics, the metrics that we track from the front end performance is quite different from what we track from a back end performance. So when it comes to front end, it's important to understand the core web vitals. So these are like the golden signals when it comes to front end performance. And the current core web vitals. So we have largest contentful paint, or LCP, which basically measures your application's loading performance. And then you also have first input delay, or FID, which basically measures how interactive your page is. And then there's also cumulative layout shift, or CLS, which basically measures your page's visual stability. So when we look at front end performance, like there's obviously like other metrics to consider, but what Google has done is they've created these set of core web vitals that every website must adhere to. Or else there's gonna be some SEO like ramifications, like your visitor count might drop and they might go to a competitor website. So you need to make sure that you need to familiarize yourself with these different core web vitals. And the good thing as well is, in terms of like learning, you also need to make sure that you are up to date with with the different metrics, because I think next year they're going to change first input delay. So they're going to remove that and they will replace that with a new core web vital called interaction to next paint. So just, it's good as well to basically know all these different like industry standards, so you can keep yourself up to date with all the different changes. There are, of course, many tools, but I think one of the most popular ones is Google Lighthouse. So it's an open source tool that you can use to improve the overall quality of your websites. Apart from measuring, performance, Lighthouse can also run audit for accessibility, for SEO. But then one thing to consider is Lighthouse only uses lab data. So if you want to check how your real users are using it, you have to use it in conjunction with other tools or with real user monitoring solutions. So what I have here on the right side, I think this is with Page Speed Insights. So Page Speed Insights basically uses field data, which is data coming in from your real users. So you can also check, how your real users are actually experiencing, your website. Apart from those tools, I've also used tools such as web page tests and even frameworks like Playwright and Cypress. They also provide a way to measure web performance via certain plugins and APIs. Main advantages of doing front-end performance. So when you test for front-end performance, this gives you a measure of your application's overall user experience because it's very close to what your users see. We can also argue that scripts can be easier to write, and most test engineers, we are familiar, and we started with browser automation, so we could argue that doing front-end performance might be easier. And it also validates this golden rule of web performance. So this basically states that 80% of performance issues are actually coming in from the front end. So if you focus more on the front end performance, then you can eliminate 80 to 90% of your issues, and then you can then focus on the 10% or you can then focus on the 10 to 20% of your backend issues afterwards. There are limitations, of course, if you only do front-end performance. So with front-end, it doesn't really look under the hood. And, without the appropriate load, it doesn't really test under realistic traffic conditions. So you can try and do browser-based load testing, and I know companies are also offering that. So this is where you generate the load by starting multiple instances of browsers and interacting with your application, the way that your real user would do. But we can argue that, browser-based load testing can be resource intensive and it can be costly. If you only focus as well on doing front-end performance, this can sometimes lead to misleading results, especially when you scale. So what we have here is you can see that as the load increases, the response time for the front end, it remains fairly constant, but it's not the case with the back end. So this occurs because most of the front end performance tests, it doesn't really compound into bigger issues, because whenever something is slow on the front end, it could just be slow for one user and not necessarily for all the other users out there. However, if you have a lot of traffic arriving at your website and then your backend, starts to struggle with the increased concurrency, then the backend time will grow exponentially, and this will impact not just one user, but your entire user base. So this is where you really need that approach of doing both front end and backend performance testing. Okay, so to get the best of both worlds, what you might do is you might try this hybrid approach of performance testing. So this isn't really entirely new. You can try to do a hybrid performance test by basically simulating majority of the load on the protocol level, and then at the same time, you have one or two browser virtual users accessing the front-end application. So you can do this, with different tools. So you might encounter like other problems because of like using different tools can have different approaches. So in terms of test maintenance, you might, have some problems. So what you can try and do is, why don't we use the same tool? So a common problem when testing both front end and back end is script duplication. Like you might have a script running on the front end, and then like suddenly you might have like a same sort of like similar protocol test, which is a bit similar in the backend. So you end up with doing some script duplication. So this could mean as well that if you're using two different tools, you might use two different scripting languages, which needs to be maintained separately. And while this is a totally valid approach, maybe it's much more sustainable, to look for a tool that can target both types of performance. And this is what K6 is trying to solve. So, to anyone not familiar with K6, it's a modern performance testing tool that aims to provide the best developer experience when it comes to writing performance tests. And now we're actually slowly transitioning to be a reliability testing tool, because K6 can also support browser testing or chaos testing, just to name a few. So we in K6 we have a module called K6 browser. So this started off as an extension, and then now it's an experimental module, and it basically has a lot of inspiration from the Playwright API. So it makes it easier for people to get started because you don't need to learn a new API. So the idea with K6 browser is, when you mix this with a K6 protocol test, this can give you insights, and it can answer questions like when your API is receiving a high number of requests, how does it impact, the end user experience? So how do we see this in action? So I have an example code here. So as you can see, it looks fairly similar to Playwright. So this is just visiting a page, going to a sample test URL, logging in, and then verifying if after you've logged in, if we can see the correct text locator for the H2. And then imagine that on the same script, you also have a protocol test. And on the protocol, you're just, doing a get request to a specific endpoint and then verifying if the status is equivalent to 200. The real magic here is, since, you can do it in a single script, you can define different scenarios for your browser and for your protocol. So in K6, so we have this concept of scenarios, which lets you run tests concurrently. So the first option is for the browser, and I'm just saying here that I want to, run a browser test, and then I want to, use the Chromium type. At the moment, that is the currently supported browser for K6 browser. And then at the same time, I have some protocol tests as well, where I have, more than one virtual user who's just, trying to send a consent request for about, 30 seconds. When you run this test, so in K6, you just need to do K6 run and then the file name. You're then presented with an aggregate view of the different metrics. So you can see from the top all the different browser metrics, including the HTTP requests that are triggered from the browser. And then at the bottom, you have your backend performance, metrics such as the HTTP request duration, the HTTP request failed. So as you can see here, it's all aggregated, and then it's then up to you to visualize these different metrics in a dashboard that you want. If you do want a copy of the GitHub repo, so I've added a QR code here, and this basically shows you the full example of how to achieve this hybrid approach to performance testing using K6. And just some final words. So hopefully I've demonstrated that both front end and back end performance, they both affect what your end users think of your application. if the underlying application responds immediately to your request, but then if you have, let's say, this huge picture of a crocodile that's making your homepage really slow to load, then your users aren't going to like that. On the other hand, if your homepage is really fast, it's quick to load, but then your application server hasn't really responded with the data that your browser needs, then again, your users won't like that. So whichever tools you end up using, it's really a good idea to test both front end and back end and try this hybrid approach. So I hope you learned something new today. Thank you.
Thank you very much, Mary. I am pretty sure that there have been quite a lot of things that we got to learn, right? And of course, the uh, audience here, the listeners, have enjoyed the session.
Mm-hmm. Yeah. Yeah, I think I'm just gonna go and quickly just go over the different questions. I
Yeah.
think Vaishali, you asked what is an ideal essential roadmap to start journey in performance testing. Matthew has written an extensive answer already. So I highly recommend that you start looking at those as well, because I think with performance, like, there's not really one sort of roadmap that I can recommend. Like, it's up to it totally depends on what your performance testing needs are, if it's front end or if it's back end, or if it could be this hybrid approach. But if you want to look into this hybrid approach, you first need to focus on either front end or back end performance. So if your team is more on the back end side, then maybe you can look at API performance or back end performance. But if you're part of a team that's catering more on the front end performance, then maybe start looking at those. What I would recommend, though, and I think this is something that people tend to skip, is when it comes to performance, we do have the actual measurement of performance, but at the same time, there's also the perceive measure. So this is where it's useful to also learn about the different techniques on, like, how a user perceive the speed of your application. So even like the type of animations that you're using, that can have an impact as well. So there's like a whole other techniques out there that you can use to improve the perceived performance of your application as well. And then from Rafael, Arturo, in which test level do you prefer to perform the larger amount of performance testing? Yep, this is a really great question. So I think when it comes to the different load testing types, so if you're looking into this shift left approach, then that's when you can do the smoke type of load testing, where you're just going to run a very minimal amount. And if you want to perform the larger amount of performance testing, so this is where you can try and do it. Like, if you have a pre-production environment, I think most companies, they do provide like a pre-production, but I know some companies, they don't have a pre-production environment. So if you're lucky, if you have a pre-production, then I would recommend playing around with, I guess, the different load testing types, but just make sure that you let, I guess, other teams know that you're also running some performance tests, especially if you're targeting to do some stress testing, spike testing, or soak testing. If you want to perform, I guess, an amount of performance testing in production, you can do, but you just need to be careful, and maybe you can reduce the number of load as well, because you don't want to take down your production environment. From Giant, could you delve into the intricacies of how this approach intelligently combines virtual users and real user data to provide a more comprehensive performance analysis? Okay. So with K6 browser, so again, what you can do is you can try and combine, one or two browser virtual user. So whenever you're, I guess, writing a script, like this is all from a controlled environment. So these are all, like I guess like synthetic data. The great thing with K6, now that we are part of Grafana Labs, it makes it easier to, I guess, also use like the other tools that Grafana is offering. And one of the tools that Grafana has recently created, and I played around with this tool just a couple of weeks ago, is Grafana Faro. So Grafana Faro is basically a real user monitoring solution for the front end observability. So what you can do is you can try and use K6 for the synthetic side in terms of, getting some early feedback on how your users are experiencing your website. And then on top of that, you then have to use another real user monitoring, like solution such as Grafana Faro or something that's equivalent to see, the data as well that your real users are experiencing. So you can try and, I guess, have like a mix and match approach. Like don't just rely on like just using, synthetic data. You also need to get real data. If you just want to have a quick, I guess, overview of like real user data, I know you can use tools like the Chrome user experience report. So it's a very great tool from Chrome that, they basically gather a large amount of data set. Or you can also try Google Search Console. So if you have, I guess, like a team that is, not really more on the technical side, but they just want an overview of how much of their pages are, I guess, like behaving well, or pages that aren't behaving well, then you can easily look at Google Search Console and see the different, I guess, like performance metrics as well. But the caveat with these real user data is it's much more, I guess, difficult to see the changes that you're doing. Because if you try and improve, let's say, a like a part of your code or part of your application, you need to wait for, I think with Chrome user experience report, it gets refreshed every 30 days or something like that. So this is where you need to use synthetic, tooling. You need to use like K6 browser or like K6, and then see what the measurement is, and then you can wait, I guess, after 30 days once the real data has refreshed to see if, your changes have made any impact. Can you please shed some light on using K6 for load testing of SQL or NoSQL databases? So in terms of like using K6, I know we do have some extensions out there that's been created. So I haven't used it myself, so I can't really expand on it a bit. But if you head over on our K6.io and then search for the extensions page, you can then have a look at, sample extensions out there that you can use for load testing the different databases that are available. um, so there's a question from Yogendra, but I can see there's some comments here. um, yeah, I think there's already some, answer here, especially from Elena. She said that, yep, you can use scenarios, and you can basically create the variables from one API and then transport that to another API. So K6, yep, also does this. So I guess it's just the same approach here as well. um, Doing from Matthew. So doing continuous testing on front end applications is a challenge because of potential changes at protocol level. Do you see XK6 browser becoming leverageable at some point to help detect outdated automation at protocol level? Yeah, that's an interesting point. Because I guess, yeah, I think with this, like, you're absolutely right. So if there are potential changes at the protocol level, like sometimes, yeah, it's I guess it's hard to do that continuous testing approach, because it might impact the front end in a way that will break the application. But I think with K6 browser, what we're trying to check or like achieve here is, because K6 on the protocol level is quite mature already, we want to bring the same maturity on the browser level. So hopefully the idea is, if you try and leverage K6 browser as earlier on, because it's using the same sort of ecosystem as K6, then it should be easier, to detect any of these errors, at the front end level that was caused by the protocol level. Um, from Nisha, is there any one-to-one migration possible for migrating existing JMeter test to K6? If not, do you plan to incorporate the feature to onboard more users? That's a really good question. From what I know, I don't think we have any one-to-one migration, extension or anything like that at all. Maybe I can, discuss this with our like DevRel team or like product team to see if this is something that we can do, because I guess this is quite hard. Like, for example, if, like, let's say if we talk about Cypress and Playwright, like if Playwright or if Cypress user wants to migrate to Playwright, or if the other way around, like, you really have to, I guess, update your test scripts. So yep, it's just the same with K6 for now, unfortunately. From Matthew again, are there any ongoing efforts to reduce resource footprint for browser level replay? Ideally, we wouldn't ever use protocol level again to automate UI process. I'm not sure if I understood the question correctly, but if it's making sure that, I guess, you don't want to use any script on the protocol to automate UI process. So we're slowly building up the K6 browser API. Our goal is to, match the Playwright API, ideally. So most of the, user journey flows that your users are, using on the browser level, the idea is we want to also mimic that with K6 browser. So we do have an open issue in our GitHub repo, which basically tracks, what API we still need to support. But the team is very much working towards this Playwright API compatibility. Cool. I think looking at the time, we have 1 more minute, so I won't be able to answer any of the questions. But feel free to reach out. So I've got my LinkedIn profile and my Twitter profile. So if there are any other questions that I haven't asked, feel free to send it my way.
Thank you very much, Mary. I really appreciate you taking out time. And for those folks whose questions have not been answered, we'll put the link to our community on Lambda Test. Right, you can post your questions there, and we'll try to answer all of them. Right. So on this note, Mary, once again, really appreciate your time and taking us through the journey of performance testing. I'm sure that everybody has learned something, and so did I.
Thank you. Yeah, thank you so much. Yeah, I enjoyed presenting today.
Great. So, on this note, let's end the session. I hope you all have a good day ahead. Bye.
Thank you.